Use functions involving e. The number e is called the natural base because it turns out it occurs a lot in nature, or the Euler number after Leonhard Euler. The natural base e is approximately 2.72. We can approximate its value by taking a look at what happens to the expression that comes from the compound interest formula. The 1 plus 1 divided by n, all raised to the nth power. So we took out the rate and the time, and we're just looking at what happens when the n value increases to a larger and larger number. So as the number of times we're compounding continues to increase, what happens to the number? So grab your calculator. We're going to figure out what does happen. So first you're going to do 1 plus 1 divided by 10 raised to the 10th power. So when you type this in the calculator, you should get approximately 2.59374. We're going to keep changing the power of 10. So next we'll do 10 squared, which is 100. The approximation for that is 2.70481. And then if we change it to 10 to the third, that's 1,000. This gives us 2.71692. Change it to 10 to the fourth, which would be 10,000. So this is approximately 2.718. If we do 10 to the fifth, that's 100,000. And that should give you approximately 2.71827 if you type that into the calculator. So we can see that we are approximating the value of e. E we approximate is 2.72. We get that from the non-terminating decimal. Which if you take that out to 11 decimal places is 2.718281828. So we can see that as the power of 10 is getting larger and larger, our approximation is getting closer and closer to the actual value of e. So the natural base e is irrational, meaning it can't be written as a fraction. It's a non-terminating decimal, and we define it as follows. As n approaches infinity, one plus 1 divided by n to the nth power approaches e. Or approximately 2.72. So if we think about the compound interest formula, if it were possible to have it compound infinitely many times, so consistently every single second, as many times as possible, we would get e for this part of the expression. Remember that e is just a number, so we can operate with it just like we would any other number. So if we have e to the 4th times e to the 7th, exponent rules tell us we don't change the base, we simply add the exponent. 4 and 7 gives us 11. Number 2, 12 divided by 6 is 2. E to the 6th divided by e to the 1st gives us e to the 5th power. Number 3, the whole thing's raised to the negative 2nd power, so I'm going to put it in the denominator. And square it. 2 squared is 4. And we multiply our exponents and we get e to the 8x. So it's 1 over 4e to the 8x. E is found on your calculator as well. You can find E on the left-hand side of your crossword calculator. It is written in blue above the LN button, which is the 3rd button from the bottom. So if you press the blue 2nd button and then the LN button, it'll give you the E, and then you'll just enter the exponent you want. So for this first one, you're going to hit 2nd LN button on the far left-hand side toward the bottom. Type the 5 for the exponent, hit enter. And it should tell you that e to the 5th power is approximately 148.41. So again, we're going to press 2nd and the LN button. I'm going to type negative 0.03. And it should give you the approximate value of 0.97. For number 6, e to the 2/3 power. So press that blue 2nd button. The LN button should bring up the e for you. Type 2 divided by 3 for the exponent. Make sure you put that in parentheses. And then it should give you the approximation 1.95. So one of the main reasons that we're talking about E, especially in this chapter, is to take a look at how we can use it with compound interest. So continuously compounded interest means that your interest is compounded continuously. The amount A in an account after t years then would be given by the formula. Your total amount will equal your principal times e to the RT power. Sometimes this is referred to as the PERT formula because it looks like PERT. P is the principal, R is the annual interest rate expressed as a decimal, T is your time in years, and then E we just discovered is what we get if we take the 1 plus 1 divided by n raised to the nth power and increase the number of times it's compounded to an infinite amount of times, as many times as possible, so compound it continuously. So our first example says you deposit $4,000 in an account that pays 6% annual interest compounded continuously. What is the balance after 1 year? Well, the amount you deposit is your principal. 6% as a decimal is 0.06. Compounded continuously means we're going to use the PERT formula versus the original compound interest formula we talked about. And balance after 1 year means t equals 1. So your total amount will equal that principal, your initial investment of $4,000, times e to the 0.06 times 1, or just 4,000 times e to the 0.06. Remember, we're talking about money, so we're going to round to 2 decimal places. And if you type this into your calculator, you'll type 4,000 times the blue 2nd button, the LN button to bring up the E. You'll type 0.06 for the exponent, and then you'll hit enter. When you do that, you should get approximately $4,247.35. So let's go ahead and take a look at some more examples. Number 8 says you deposit $2,500 in an account that pays 5% annual interest compounded continuously. We're asked to find the balance after each amount of time and then found the amount of interest earned. So here's our deposit. So that's our principal. 5% as a decimal is 0.05. Compounded continuously tells us we're going to use the PERT formula. And the first one says 2 years. So A equals PERT. So our principal was $2,500 times E to the 0.05 times 2 for 2 years. So A equals 2,500 times E to the 0.1 . So it comes out to be approximately $2,762.93. Since we initially invested $2,500, if we subtract the two, we'll find out how much interest we made. So $2,762.93 minus $2,500 shows us that the interest earned is $262.93. For the second example, we just changed it to 5 years. So still $2,500 for our principal, still E to the 0.05, but this time times 5. And if you type that approximation into your calculator, you should find that the balance is $3,210.06. So if you subtract out the $2,500 you deposited, you'll see that you've earned $710.06 of interest. And then they want us to change it to 7.5 years. So if we type that expression into the calculator, we'll see that they would have $3,637.48 at the end of 7.5 years. So if we subtract from that the $2,500 that they initially deposited, they'd earn $1,137.48. So that's how we apply the formula for compounding continuously, rather than compounding monthly, annually, semi-annually, daily, and all of the others we talked about with the original compound interest formula. As soon as you see the word continuously, that's when you know that's your keyword that you should be using the PERT formula.